Every year, over 1.6 billion passengers take one of Europe's annual 10 million flights, expecting a smooth journey, baggage on arrival, and without delays or cancellations. With traffic projected to hit 16.9 million by 2030, more flights could mean more delays, greater safety concerns, increased costs for airlines, and higher CO2 emissions. Only an air traffic management system that is fully equipped with the latest technologies and operational procedures can efficiently handle this situation. This is where SESAR comes in. SESAR, with a budget of 2.1 billion euros until 2016, is a research and development program aiming to modernize the entire European ATM system. SESAR does so by pooling together the knowledge and resources of the entire ATM community through a public-private partnership, the SESAR Joint Undertaking. As the technological pillar of the Single European Sky, SESAR is developing solutions for EU skies to handle up to 3 times more traffic, to improve safety by a factor of 10, to reduce the environmental impact per flight by 10%, and to cut ATM costs by 50%. To achieve this, the program and its partners are delivering a steady stream of tangible, technological and operational solutions. These solutions meet the needs of ATM stakeholders for today and tomorrow and have been thoroughly tested, proving their merit for deployment. More solutions are on their way, but some are now ready for industrialization. User-preferred routing (UPR) enables aircraft to freely plan a route without referring to the Air Traffic Services (ATS) network. UPR is a step further in the European free route airspace concept and is an essential component for a modern air traffic management system. With UPR, the operator's flight planning system calculates the most efficient route between departure and destination, taking into consideration wind speed and direction, turbulence, temperature, and the aircraft type and performance. Validation exercises in the MAASTRICHT Upper Airspace Control Center have made steps towards UPR by focusing on extending the use of direct routings inside a complex area. They found that flight distances could be reduced by 5% and flight times could be reduced by 2 minutes. Direct routing also proved to be cleaner with up to 12% reductions in fuel burn and emissions. Today, ATM systems can detect high traffic density but have no airspace tools to find alternative solutions. Automated support for dynamic sectorisation provides an alternative, enabling air traffic controllers to adapt airspace configurations in order to best meet traffic demand at peak times. With dynamic sectorisation, airspace sectors are grouped or degrouped to match capacity and cope with evolving demand. The result is better use of available airspace and human resources. Tests in Barcelona demonstrated that thanks to dynamic sectorisation, traffic capacity is increased by 10%, even in saturated periods, while the number of delayed flights is reduced by 5%. Not only that, because they receive advanced warning, the ATM system is better prepared to manage these situations. Today, airplanes making their final approach to land are obliged to maintain minimum distances. These distances are fixed whatever the weather. When keeping to these distances in strong headwinds, longer gaps of time develop between airplanes. This means fewer flights landing per hour, delays, and increased holding at busy times, which in the end results in increased fuel burn. Time-based separation, TBS, replaces current distance separations with time intervals in order to adapt to weather conditions. Tests at London Heathrow demonstrated that TBS allows up to 5 more airplanes to land in an hour in strong wind conditions, while reducing holding times up to 10 minutes. Thanks to TBS, we're seeing increased safety, fewer delays, and improved environmental performance. SWIM is the intranet of the air traffic management. It enables seamless information interchange between all providers and users of ATM information. They share aeronautical, airport, flight, meteorology, surveillance, flow, capacity and demand information. SWIM gives the right person access to the right information at the right time and in the right and secured way. Demonstrations so far confirm that SWIM allows greater ATM operations efficiency and ATM infrastructure cost reduction thanks to interoperability of systems based on standard technology and information services. It also opens the opportunity for the development of new SWIM-compliant applications and systems. The first I-4D trajectory flight trial took place in February 2012. It was a world premiere. 4D means 3 spatial dimensions plus time. Time represents a key element in the transition from constrained flights in the current ATM system to optimized flights. I-4D operations establish far ahead of time a sequence for aircraft converging on a merging point, which is particularly crucial in congested areas. After coordination between the ground systems and the aircraft, each aircraft is allocated a time slot for its arrival at a merging point, and in compensation is allowed to fly to that point without any vectoring instruction from the controllers. Current validation exercises and flight trials have demonstrated several reductions, in average time spent in holding up to -100%, in distance flown per flight -6%, in number of potential conflicts by -68%, and in average fuel consumption per flight -11%. In the future, thanks to I-4D trajectory, ATM operations will be automated to a greater extent than they are today, and the European sky will be able to cater for more efficient flights than it can today. Extended Arrival Manager Horizon allows handling of air traffic much earlier for the preparation of the landing sequence, thanks to the coordination of terminal maneuvering area and en route air traffic service units. Air traffic controllers are able to extend the borders of the terminal maneuvering area into the upstream airspace sector and instruct pilots to modify aircraft speed before the top of descent. They can thus calculate a smooth and optimal arrival flow to maximize runway throughput, relieve congestion, and minimize arrival queuing time. Flight trials have already taken place in Rome, Amsterdam, Malmö and London, achieving an average reduction of 8% of fuel consumption per flight and a reduction of 78 to 87% of airborne waiting time. These are only a few examples of the impressive solutions that SESAR has already delivered to date. More solutions are on the way, meeting the business needs of Europe's ATM system for today and tomorrow.